Recording in progress. Okay, so I've managed to somehow figure out how to get this thing recording. I've got at least an R session loaded, although not the one I want. Um, this is sort of the joys of doing data analysis. As you guys get into your careers, especially if you're going to be in sort of a finance or financy or like a data analysis adjacent career, you're going to find that you're going to moonlight as sort of the IT specialist, and everyone's going to come to you with all your IT questions because you're going to suffer through a lot of IT challenges like we're doing this morning. And so, just giving you guys a little bit of a heads up that you didn't may not necessarily want to be an IT professional, but by hook or by crook, you're going to become one uh, later in life. Nevertheless, yeah, let's go ahead and just do a quick recap of what we covered last week, just so we're kind of all on the same page. Again, we learn how to get our work environment updated and loaded up. That includes getting some packages installed. Really the primary one that we're going to be working out of, and the one that you're going to be working out of almost exclusively from here on out, is going to be the Tidyverse package. And with Tidyverse, we get a bunch of neat stuff like how to do data manipulations, how to do plotting, and to do it in a way that is really clever and to do it in a way that we think. That is through what is called the pipe command, which is this little, uh, well, technically this is what we call a pipe. It's a sort of like up and down thing that is on your keyboard right above your enter key, and then the greater than sign, and that allows us to take data and pipe it into a function, and then from that function, pipe it into another function until we get to something that does sort of what we want it to do. If we want to output a table, we can output a table. If we want to output a plot, we can output a plot. Um, those things kind of just sort of matter depending on what it is that we're trying to do. For the last couple lectures, we've been dealing almost explicitly with plots, really kind of hammering into you guys sort of, what is a line plot, what's a histogram. We did even density plots, kind of like what we have here on the right-hand side. Um, and yeah, we were just kind of having a lot of fun with those sort of kind of, I guess, sort of big three key elements. The last thing that we ended on was this credit card data set. If you recall, credit card was kind of a fun data set that had a bunch of, or a sample of credit card applications to a credit card company, and it had whether or not the application was accepted or rejected. So whether or not the credit card issuer issued credit to the applicant, um, indicated by the yeses and nos. And then it had a bunch of different kind of qualifying information along with it. So how many delinquent reports were in their credit file, their age, their income, whether or not they're a homeowner, how long have they been living at their current address, number of dependents, and then their various kind of their various income related data. So yeah, and that's kind of what we landed on. What we saw, the key difference between like a density plot and a histogram. Histograms are really good for looking at discrete data. So if we have, let's say, like a small amount of data, like we had with the bank wages data, which I think only had like about 500 observations. Um, those types of data tend to work really well, usually because we have only just a limited number of observations. We have some limited number of buckets, and we're probably going to see some pretty unique things in our data set that we don't necessarily want to look at on, let's say, like a denser view. So, for instance, if you remember with the education, I'm sorry, years of education, they were all clustered around these sort of like, I guess it was like three kind of key things. There was one where like it was there was a cluster around eighth grade, there was a cluster around 12th grade, and then there was some clustering around college and then graduate school. And so doing a histogram. Oh, your yawns are contagious. I apologize. Um, Having those, being able to express those clusters discretely is really where histogram shines. Where the density plot really does sort of stretch its legs is when we have a much richer set of data. So this credit card data has three times as many observations. That kind of gets in the ballpark of when we want to, perhaps use a density plot. Um, and the data itself, excuse me, is going to be behaved in a way that is probably um, you know, expressive more of like kind of population level statistics. So looking at just say like, was a credit card declined, yes or no? Or what, looking at, the number of active credit cards that are in their file. What was another plot that we did? Let's see if I can go back here. Here we go. Their income, right? Expressed in tens of thousands. Um, there's going to be some kind of clustering around this 25,000 at the time of this data. This $25,000 a year mark, um, and whether or not they were accepted or rejected, so on and so forth. So yeah, that's kind of where we landed. As I was talking to Gabrielle earlier before you guys jumped on, we're about a day ahead. And actually on the homeworks, I got you guys a little bit farther ahead than I thought that I would have had you. And so get a little bit of reprieve over the weekend with no homework. But today we're going to tack in a little bit more deeply into data manipulations, which is something that we kind of have done a little bit with. Just in terms of sort of getting the data in the right way for our plots, but we're going to do it in a little bit more deliberate way today. So before I get into that, does anybody have any questions so far? 8 a.m. This is going to be hitting you like a fire hose, and I do apologize. But we will have the lectures on YouTube here as soon as we close out class, and I'll post up some lecture notes for you guys. I haven't been doing a whole lot of lecture notes because I like to use the R script here. I think that that's a great way to just go in and start typing, and you can kind of see the flow of work. Although I think last Thursday I did a pretty poor job of commenting out my stuff. But that's kind of typically how I operate. And if you guys go into the help files, um, what you'll see on the bottom are just a bunch of examples. And so that's kind of how I learned is by example, seeing other people do the work or, you know, searching online for a question that someone had asked and seeing how they do. But in here for this lecture, I definitely want to get this posted up for you guys. I still don't have a Canvas page yet. So I'm just going to email you everyone out the PDFs themselves and we'll deal with it. We'll have fun. This will be great. Let's see. Where do I want to begin? Do, 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 do. Let's go ahead and start with, let me see. We've done that. We've done that. We've done that. Let's go straight into data manipulation. Let's go ahead and load up. I'm going to start, if you will bear with me here, a new script. I'm going to rename this one as week 1. And I'm going to call this one, save this as week 2. And I'm going to start up the top here. Copy this over here. Let's go. So for today's class, we're going to work with a data set called NYC Flights 13. NYC Flights 13. Let's go and get that installed, if you would. Oh, nice. Excellent. That was quick. And let's get that loaded in. So if you guys remember, what do we do when we get a new data set? We always data. Let's see, come on. What? Go through and double check which one this is. Where are we? Come on. There you go. NYC flights 13. There we go. All right. So database. No, that's not what I wanted. Let's go here. NYC flights 13. Where did my data go? Did my data go? One second, guys. Where did this data go? Should have loaded. Where did it go? Let's go to down here. Let's go into our packages. Doing it live. I want to see flight 13. There we go. There we go. All right. Fantastic. Oh, that's why. Data. Oh, data flights, of course. And let's go into flights. So in this NYC Flights 13 package, we've got looks like 5 different data sets. I've got weather, planes, flights, airports, and airlines. All right. Well, what does all that mean? So let's click on flights. And this is on-time data for all flights that departed New York City. So JFK, LaGuardia, and what's EWR? I'm not sure what EWR is. Um, in 2013. You guys know what the EWR airport code is? I don't. Let's look that up. We can look that up very easily. EWR airport code. Newark. That was Newark. Okay, cool. So JFK LaGuardia in Newark in 2013. Do you think it's going to be a lot of data or a little bit of data? It's every flight leaving 3 of the busiest airports in the world. It's going to be a ton of data. It should be a ton of data. And so if I do a glimpse here, down on the bottom, I should get, yeah, this is a lot of data. So you'll see that we've got 336,000 rows of data across 19 columns. So the data that we have here is, so right away. The data that we're working with, is the year. So this should all be 2013. The month. So if this is, so what values do you think is going to be in the month? Right? 1 through 12. The day, roughly 1 through 31. Departure time, scheduled departure time, the delay, so the difference between these two, arrival time, arrival delay, the carrier, the flight number, tail number, origin, destination, how long they were in the air, distance, and the hours and the minutes. So in terms of the clock, and then the time hour in the day and the time. So if I go into here, into our format, we can kind of see the exact same thing. Year, month, day, departure time, arrival time. So this is in time, hours, and minutes. When they were scheduled, to the extent that there was a delay, how much was there a delay? The carrier, which is the abbreviation. We'll get into some of this stuff later. Origin, arrival time, distance, hour, minute, so on and so forth. So this is a pretty rich data set, right? This is everything that's coming in and out of the New York metro area in 2013. And predictably, there's just a ton of data in here. Let me go ahead and share up my notes here. Let me see this. Stop share, and let me share this. Share my screen. Where's my notes? Share. All right. Oh, wrong one. That's not the one I want. That's not the one I want either. I promise you guys, we're going to get there together. Also, quick question for you guys. Where does this data come from? What is the source on this data? Where do we find that? Anybody?
Is it in the help area?
Yep, yep. Actually, yeah, now I got my screen right. If you go to the very bottom of the help file, sometimes they tell you at the very top, but there should be there's usually a section called source, and you can see it on the bottom. Um, it'll say RITA, Bureau of Transportation Statistics. And so this comes from the NTSB. Is it NTSB or Bureau of Transportation Statistics? Sorry, the Bureau of Transportation Statistics is where it comes from. So whenever you guys are doing any plots or you're referencing this data, you can give the proper attribution to it. What's also nice about this is that these are official statistics. These have been scrubbed. Um, and so it's not something that you really have to necessarily worry about the provenance of that data. Um, so does anybody have any questions before we tack into data manipulations? Nope, we're good. Cool. Okay. So data manipulation, just like we've been doing with plots, has verbs, right? So we start with some data, like that's our noun, and then we have a verb, which is what we're going to do with it, and that's kind of like our function, right? And sort of the main verbs that we typically deal with are going to be verbs that allow us to pick or select our variables, right? So if I want to trim down my number of selections, I can use the filter, right? And so what filter does is just like it does in Excel, right? Is it just filters the observations based off of the criteria that we're selecting. And if you guys recall from, I think it was like Tuesday or Wednesday, we did a little bit of filtering of some of our data sets. I think it was the cigarettes stock Watson data. We had filtered by a selection of states, right? Um, we can also not only select by filtering applies a logic to specific rows, right? And so you're going to manipulate how many rows of data that you are gathering or that you're then passing off to your next function. Select, which is almost as important, does the same thing, but you're selecting which columns of data you're going to pass to the next function, right? So for instance, in our data set here, this New York this flights data that we have, um, a filter command that we might want to apply is in 2013. Let's just pretend for grins that the Super Bowl happened in the month of February in New York City in 2013. And I want to see all the flight activity that was around that major event. Or even better yet, let's think about maybe the 4th of July, right? So 4th of July is a massive event in New York City. Everybody wants to come in for the massive fireworks display. It's a huge thing. And so, I would filter on the month column, right? And if I did, let's say, a filter month equals 7, I would be filtering the observations that only were in the month of July, right? If, for instance, I have, currently 19 columns in this data set, if all I'm really concerned with is the let's say the lateness of departure, right? For flights that are coming into the New York area for that particular month, I may only have the departure sorry, the departure time, the scheduled departure time, and the departure delay. Right. So I'd only need really three variables. And so I could just limit the amount of data that I'm now passing into my functions just to those three columns. And I could just select those individual three columns for work, and I would be discarding everything else. Does that make sense, guys? So filter applies to rows, select applies to columns. One thing to be aware of, though, and this is something that some students, have a little bit of a hard time with, is the fact that once you have performed these operations on your data set and you're kind of going through your pipes, whatever data you're now excluding is no longer recoverable in that function, right? So the data is still there in your data frame. It hasn't gone anywhere so long as you're not reassigning the output back over to your data frame. But insofar as you're trying to, let's say, plot it or create a table or just try to get some sort of result, once you've filtered or selected on those particular criteria, whatever you're now excluding is no longer a part of that data. And so you're going to have to kind of come up with a way to bring it back in somehow. And we can kind of go over some strategies a little bit later. But those are just really kind of the things to be aware of. If I want to reorder the rows, I can use the arrange, right? So for instance, if I've got it sorted in ascending month or ascending time, I can rearrange it to descending, or I can arrange it by the airline. And really what that does is just, like you would with sorting in Excel, right? It does pretty much the same thing. And what that does is it really just sort of cleans up the data set a little bit. So that way, as you're kind of scrolling through it, makes it really easy to kind of go through. Mutate and summarize, we've already kind of gone through those a little bit last week. Mutate creates and edit creates new variables and edits the values in existing variables, right? So mutate, as the word would sort of imply, changes your data set, physically changes your data set, right? So if I did a mutate on a data frame and then I went back into that data frame, those values would still be changed. Summarize, again, collapses the data down into a single summary, and we can do a summary based on the count of flights. We can do it in terms of the average departure delay, right? We can, summarize these things, but we're taking all those rows so mutate maintains the number of rows of data, right, in its output is the best way to explain it. So if I do a mutate and I've got 300 and some odd thousand rows of data, my output is going to be 300 and something rows of data. If I do a summarize, my output, potentially could just be one row. And that one row could be the summary for all that data, right? So the summarize collapses that data down into a single summary statistic. Does that make sense? It's a little bit of a review, but the nice thing about tidyverse is that the words kind of do what they mean, so there's not really many surprises here. It's not like you have to learn like a new syntax. And then we can also use what's called group by, right? So I'm sure you guys could probably venture a guess what group by does. Group by just groups things by a particular column. So if I wanted to get the average delay by month, I could do a group by month and then do a summarize pass that into a summarize. Um, so we've kind of gone over this already before, right? All verbs sort of work similarly, right? Like the first object we start with, our noun, is our data. We pass that into a function. That function does something to the data, and then it spits out something, right? So if we're dealing with data functions like filter, summarize, mutate, they're going to pass a data object. If we're dealing with something like ggplot, that's going to pass a plot, right? And the nice thing about dealing with this sort of grammar framework is that we can just keep passing things so long as they're the input for something else, right? And we can think of that little pipe command that we've been dealing with, that the up and down kind of bar and the greater than sign. We can treat that in our heads as like a and then, right? I started with data and then I filtered it. And then I grouped it by the airline. And then I generated a summary of the average delay, right? And so let's go ahead and take a look at that with some of this data. I'm going to go ahead and move over to my work environment here. Let me share up. Share. So you guys should be able to see my workspace. You're able to see this clearly? Is that good? Okay. I can never tell like sort of what it looks like on your end. Let's save this. So let's just we did a glimpse flights. We got this down below here. So let's start with flights. And then, let's say I want to, let's just do a simple group by. Let's do a group by. Let's group by I don't know. Let's group by month. And then I want to do a summarize. Let's say average delay equals, and down here, actually it's specify average departure delay. Average departure delay equals, let's say average departure delay. So to do the average is just the mean. And I'm going to do depth delay. And I'm going to go ahead and just run that. So what I want to do here is do data. So we're going to group by month, and then we're going to summarize what the average departure delay by month is. So let's go ahead and do that. And I get a bunch of NAs. Row, what do we do now? So if I go into this departure delay field, it probably doesn't treat. So actually, let's go ahead. This will be a good exercise. Actually, this actually works out really well. So I've got these NAs, right? And so R, when it tries to calculate this mean, right? It takes every value in there. And if it hits an NA, can you guess what answer is going to give you? If I've got 5,000 numbers and one of those is an NA, am I going to get a numerical value or is it going to hand me an NA?
NA.
NA, exactly. This is quite possibly the single most powerful feature in R that you're ever going to run into. This is a godsend. This is your angel. This is the angel on your shoulder. This is your guardian angel. Because what this is telling you is that there's something in your data that is not a numeric value. There's something in your data that you might have overlooked. Because had you known that there was an NA in there, you probably would have done something to filter it out. You would have, you would have treated it in a certain way, right? And this is sort of your this is your like kind of wake up call to say, huh, there's something in here I didn't expect, and I better go through and figure out exactly what it means. And so this is kind of like, all right, these NAs are like the best ever. Like they kind of mess with your results a little bit, it makes life a little bit difficult. But at the same time, like they're really nice because they tell you that there's something else going on in your data. Um, and let's go ahead and add a comment here. We ran into NAs. What do now? Well, there's two ways we can treat this, right? One is that we can explicitly filter them out. So one is explicitly filter them out with filter. All right. So the first thing we can do, one of the two things we can do is we can well, there's actually three things. I'll get in the third one later. But the first thing we can do, right, is filter them out. So I can do a filter, right? And there's a function in R called is.na. And what is.na does is it passes a true and false, right? If it's NA, it's true. If it's not NA, it's false, right? So I can put in departure delay. So if this is going to pass a true, that means it's going to return all the columns, or I'm sorry, all the rows that have an NA in departure delay. Is that what we want? Or do I want the opposite of that? Do I
Yeah,
only want NA values or do I want values that are not NA?
values that are not in.
Values that are not NA, that's right. So, and the way that I can negate that is with the exclamation point. So by using an exclamation point, that is R's kind of symbol for not, right? So I want all the values that are not NA. So I've got a function that tells me whether or not it's NA, and I'm just going to flip that around. So if it's true, I only want the rows that are going to be false. So and what, and we can actually see that. Let's go here. Let me illustrate this real quick. I'm going to go and comment this out for just a second so it doesn't mess with us. I'm going to do a view right here. And if I do that, and I go to departure delay, see I have nothing but NAs in this column, right? Why do I have NAs? Well, there's no departure time, right? So these are presumably flights that were canceled, right? So they were scheduled to depart and they didn't depart. They were scheduled to arrive and they never arrived. So I'm going to hope that these are just flights that got canceled for whatever reason. Could be a mechanical issue, weather related. Could be any number of reasons. But these are flights that were canceled. How many of them do I have in my data set? We got 8,255 in my data, right? Is that a lot? I mean, 8,000 is a lot of observations of 336,000. So I'm going to do 8 divided by 336. That's like right around 2% of my data set. Do I really care about these now? Maybe not so much, right? Like they were just canceled. Do I have to think about treating these in a specific way? Do I want to maybe give them a zero value? Do I want to, is there something in here I need to think about? Not really, right? Not really. These are just canceled flights. They were a small portion of it. As we, if you're thinking about, doing a formal write-up of the data, part of your write-up includes um, these types of challenges, like, for our analysis, we started with all the flight data coming in and out of the New York metro, the New York metro area. We initially started with 336,000 observations. We trimmed 8,000 of those due to canceled flights, right? Giving us a total of 228,000 or 328,000 observations in total, right? So it's something that you want to keep track of, right? This is a part of your data, and as a data analyst, it's sort of expected that you're going to know all the ins and outs of what's going on in your data. But you know, as far as do I have to maybe do something differently other than just sort of mentally or formally note that they're in here at this size? Not really. I think that this is a manageable size. If it was like half of your data set, okay, what's going on? Like, why are there so many flights canceled? Like, what's the data might be bad. Like, does it make sense that half the flights does that make sense that half of all flights in the United States are canceled at any given point in time? That's a ridiculous that's no, like the airline industry would collapse. If I put that exclamation point in front of the is.na, right? What do I get if I do that? Right now I get values in here, right? And I get, like we said, I get 328,000 observations that have some sort of value in here. What do you notice about these departure delay values?
There are numbers.
Huh? Say it one more time.
There are numbers.
They're numbers. That's right. Yep, they're numbers, which is good. We want them to be numbers. What do you know about, what do you see about the values that are in here?
Negatives.
Get some negatives, right? Is
Yes.
a negative a delay? I've never heard of a negative.
Yes.
Huh?
I don't know.
Yeah, exactly. Yeah, I don't really know what a negative means, right? Like I mean, in here, what it says is that it was scheduled to depart at, let's say, let's go to row 7 here. I'll highlight this one right here, right? This one was scheduled to depart at 6 a.m. and it departed at 5:55. So I now have a -5, right, number in here. So let's say I'm doing a report on the average delay out of this in our data set. Do I want to include negative numbers? I mean, this is an empirical question, like for you guys as the researcher, like that's a decision that you're going to have to make, right? Like, what do I want to do with these negative numbers, right? Because it's not a delay. I mean, did it leave on time? I mean, technically, right? I mean, it left early, if anything else, right? Like, do we expect every single flight to leave exactly at 6 a.m.? Well, of course not. I mean, did it leave around 6 a.m.? Absolutely. Yeah. Did it leave on time? I mean, I would argue it left on time, right? These to me seem like they're, kind of within range. So perhaps, as at least an initial filter, when I specify the question, did this flight leave on time or not? Right? I now want to define that, what on time means, right? And on time doesn't mean specifically at that particular moment, right? Because we're not dealing with, let's say, YouTube previews, right? I set my YouTube premiere to a video to blast out at, let's say, 6 a.m. or I've scheduled an email to go out at 6 a.m. That better go out at 6 a.m., right? That's programmatic. That's going to happen right this second. Flights, putting an airplane on a runway is a little bit of a different operation. And so, I may want to specify what this delay thing actually means. And so, I may want to define delay as any flight that left, let's say, you know, rather we'll define on time as any flight that departed um, no later than let's say 5 minutes after its scheduled departure time, or maybe no later than 10 minutes after its scheduled departure time. Maybe a way that we want to define that. So let's go back in here. So we know we don't want those NAs because they never took off. And let's say now I want to, God, we went down a rabbit hole on that one. Wow. I totally forgot. We were just dealing with NAs and we went into the philosophy of how we define our actual question in itself. That was pretty wild. Um, Nevertheless, there's two ways that we can do that second stage of filtering, right? We can do we can either do like just a simple comma, right? And we can say departure delay is greater than zero, greater than equal to zero. All right. And if I run that, let's go and view it here real quick. If I view that, now I get values in here, right? Now I get some values. So it looks like in here, the average departure delay was 30 minutes roughly across the board. If I just sort of look here, kind of eyeball it a little bit, it looks like 30 minutes thereabouts. It was the average departure delay. When there was a delay, we're filtering out those NAs, explicitly filtering them out. What if I kept those negative values in there? What if I kept them in here? Go ahead and just leave that out. Looks a little bit different, doesn't it? So if I keep those negative values in here, this says that there was only roughly a 10 to 15 minute delay on average over the course of the year, right? That's including all those times when those flights had departed early, right? But if I include them, so if I get rid of all those negative values, so I only want it when departure delay is greater than or equal to zero, right? I get a much different answer, don't I? So my average departure delay jumps from, let's say, like 10 to 15 minutes on average up to 30 to almost 40 minutes on average, right? Over the course of the year. Does that make sense? Do you see kind of the difference here? Do you have any questions about that? Nope. Cool. Very cool. Very cool. Um, there are two ways to do filtering. One way is just to do a simple comma, right? So I can filter by here, and then I can filter by here. This comma is an explicit and operation, right? So if you remember back from your kind of like I guess not category theory, but kind of like category theory, like your little Venn diagram of objects, right? The and is the interior point of those two things. So I want my data to be not NA and have a departure delay greater than zero. I can also type that out as the ampersand, right? The ampersand is a little bit more explicit. Ampersand literally means and departure delay greater than zero. So I run that, get the exact same answer, does the exact same thing. But what if I wanted to have multiple criteria, but I didn't want them all to have the same criteria? What if I wanted an or criteria? Well, I could do or with that up and down key, that we use for the pipe, the same kind of key that we use to start our pipes with. We can use that to signify an or. So let's go. We do a little thing here. One, dot A. So, and equal is, and is, or, and I think we showed you this last week as well. The other one is with the equals sign. So equals is equals. So this is an important one to kind of remember. A single equal is an assign. So that's when we want to assign a variable a particular value. Equals does a comparison. So let's illustrate that real quick. And I can stack filters too. I don't have to keep all my filters in the exact same filter function. I can stack my filters depending on what stage of my exploration I'm working in. So let's say that I get to looking at this stuff and I go, huh, I wonder what this says for let's say different airlines. So let me go here. Let's go into this. Let's go up to here. Where's my airline? Let's say origin. No, let's do even better yet. Let's do by the origin. So let's do EWR. So I can do, is it origin? Yeah, origin. So origin equals EWR. So here I'm filtering for only where the airport, the departure airport is equal to EWR. Right? And I'm going to filter by those delays. Now let's go and take a look. So we know we did something because these answers are still, they're quite a different from what we were looking at before, right? But now I see, but now I'm filtering just for Newark Airport. Right. So before when we were running the statistic running on all the airports, all three airports, here I'm just looking at it for the average departure delay. That make sense? And the last one, we went into this a little bit, although kind of not really, is the in command. And what in does is if I have a list of objects and I want to filter on whether or not that variable is contained within that list, I can use the in command. So let's say I have a list. So I'm going to say airport list equals, say, EWR JFK, JFK, right? Let's say I've got an airport list, right? And I want to filter just on these two airports, right? So origin or the equal signs really only lets me compare one value to another. But if I want to know whether or not the value that's in origin appears in this list, I can use in. I can do airports list. Okay. And let's go ahead and take out this. And actually, let's leave that in here by month. Actually, let's take that out. So I only want to look at these two airports. I want to take out my NAs and where my departure delays are greater than 0. And now I want to group by not just month, but I also want to group by the origin, right? And the month. We can separate those with commas. So I'm first going to sort by the origin, and then I'm going to sort by the month. And then I'm going to calculate the average departure delay. And when I do that, look at that. What happens? I've got my origin, right? Sorted alphabetically. And I've got my month here in months 1 through 12. And I've got the average departure delay. And this average departure delay is the average departure delay for this airport for this month. Pretty simple, right? Easy peasy. Does that make sense, guys? Do you have any questions so far? Does this make sense? Does this seem kind of obvious to you guys, or is this are you guys kind of getting up in the RPMs a little bit? Because when I first learned this, I was like, huh, what? Like, took me a minute to get my head wrapped around it. I want to make sure you guys are all on the same page. Kind of a little bit.
It says department delay is not found.
Uh, is it dep underscore delay that you're working with?
Hmm.
This is not
Yeah.
found.
Yeah.
Uh-oh. Uh-oh. Do you want to share your screen? Let's go look through it.
Mhm.
I love these. These are fun. Let me stop sharing mine. Let's see. Filter origin in airport. Good. Filter. Yep. Group by origin month. Yes. Average mean departure delay. View. It said object departure delay not found. Ooh. Ooh. Flights. That's oh, I see where you made a mistake. Go to line 29.
29.
What do you see at the end? Missing a pipe.
Oh.
Missing a pipe. There you go. Bingo bango.
Oh, okay. Thank you.
Yep, no problem. No problem. That stuff messes with me too. Like I will go through something. I'm like, what am I doing wrong? Why am I getting errors? And I will spend an embarrassing amount of time trying to troubleshoot something that is just literally a missing pipe or like a comment somewhere that's or whatever. So cool. And then lastly, I do want to show you a different way. So we can also filter NAs with NA.rm. So if I go into this function here, okay, if I go into mean, you see this little flag that I have here? You guys see that? NA.rm equals false. If I just go into the help file on the mean function, you'll see an NA.rm equals false. And quite a few functions have this flag. So like mean, count, sum, diff. They often have this flag in here, this little option here in the function to remove NAs, right? So NA.rm is a logical evaluating to true false, indicating whether NA value should be stripped before the computation proceeds, right? So if you remember, we had these NAs in here, right? And they were kind of messing up our calculation. And so the first way that we can treat it is we can just remove them completely from our data, right? We can just remove them entirely. But what kind of problems does that sort of run into? Well, the first one is that I've now removed it from my analysis. You know, anything I do to this data set afterwards, that data is gone. I can't touch it again, right? So, you know, if I want to have if I want to summarize the average departure delay and I want to say the average arrival delay, right? And there's data in one but not the other. Let's say there's a data error or there's something kind of going on weird in the data set. I may not want to exclude an NA value because it's now I'm removing everything else associated with that observation. Does that make sense? Right? So let's say, for instance, it's survey data, Let's just, take a step back for a second. Let's say it's survey data, and um, they ask you, what was your city of birth, right? Or, or what hospital were you born in, right? Maybe you know that, and maybe you don't. I don't know. Like, it's what hospital you're born in is, kind of deep trivia for some folks, and maybe they don't remember it. Maybe they knew at one point, maybe they don't know anymore, and so they're going to put an NA value in there, or let's say that they're asking a question that just doesn't apply, right, to specifically to you, um, and so you put down an NA. If we're filtering those out explicitly up front, like we are here on line 23. Any other data associated with observation is now gone, right? I may not want to chuck that out. I may want to keep that data in there. And so the other way that we can deal with this is with the NA to RM flag. So I do NA to RM equals true. Oop. And in R, we do true false is all caps, right? No quotes around it, just true or false. This is what's called a reserved word in R. So true and false are have special meaning in the R language. And so if I go in here and let's go ahead and filter this out real quick. If I go and say filter depth delay greater than equal to 0, and I pipe that in, a month, and I just go and run this. What do I get for values here? So this top one I get as 34.27. If I run this, I should get the same result. 34 point, get the exact same answers here, right? By using the NARM flag in my function, as I did by explicitly filtering out those observations from my data set. The difference is that I'm keeping all of the observations in this particular calculation instead of throwing them all away. Which one's better, which one's worse? That's up to you that's sort of those are one of the decisions that you guys are gonna have to make as you go through your data. But those are the options you do have in front of you. So you can either choose to throw all that data away, or you can choose to keep it in, but then just exclude for the purposes of this calculation, whether or not you want to include them. So you can either do it at the data level, or you can do it at the calculation level. You guys have options. That confused you guys thoroughly? Have I lost you guys yet? A little bit? Seems a little weird. It'll make a little bit more sense as you guys get into doing some heavier data analysis. But this is kind of just an important little nuance with these functions, because they give you the ability to fine tune at what level you want your analysis to operate at, right? Do you want your analysis to be at the entire data set level? Do you want your analysis to be just at that particular field? If you want it to be just at that particular field, you can use something like an NA.RM. If you want it to happen at the entire data set and you're just making exclusions up front, you can filter it out using the filter command. But those are options that you have in front of you. Where might this actually, let me show you explicitly where this occurs. So I want to do not just what's my average delay, but how many number of flights, right? Let's do n flights equals is it n. So this little n here gives me the number of observations. Right? And go to n. Come on, load. There we go, load. So n gives the current group size, right? So how many observations I have in the current group. And then I've got this down here as is. Let's go ahead and take a look, see, shall we? So how many flights do I have in here? So let's just look at this first one real quick, right? So my average departure delay across 4,850 flights is 34 minutes on average, right? That's what this table says, right? You guys follow? That's the calculation we ran. Is that true? Uh, Kind of not really, because I've got some flights that never took off in here, right? I got some flights in here that never took off. Do they belong in this calculation? If they never took off, they were never delayed, were they? They just never took off, right? And they might have not taken off for any number of reasons. So what we can do is, instead of using this na.rm, I can just filter those out automatically up front. And what do I get? Right? A little bit different answer now. So now I'm filtering out all those NAs from my data set. They look a little bit similar. It's a little bit deceptive, but these are, I think it was 4852. So this top one, I trimmed out 2 flights, but I know for the bottom ones that we did a little bit more aggressive filtering in there. I'm sure you guys can do a little replay on the video later on to find out if I'm lying or not, but nevertheless, right? These flights in here are only including those flights that had values in them. Clear as mud? Good. Cool. Let me go back on my notes and see where we are. We only have about 10 minutes left. All right. So what I want you guys to do as an exercise real quick is to, let's see now, let's just copy this down. All right. So let's go ahead and create a new data set called winter flights that has all the flights from December to February. And I want you to filter the flights that left late, but had an on-time or early arrival. Let's just work on, let's just do number one right now. Let's just do number one. Let's just work on number one for right now. So let's create a new data set called winter flights that has all flights from December to February. So we're gonna call winter December, January, and February. Let you guys work on that. Does that make sense? Give you guys 2 minutes to do that. Should be that's a quick 2-minute task. And then we'll walk through it together. If you don't get it, that's fine. No stress on this one. I'm not gonna call anybody out for this one. I'm gonna ask you to show your work. All right. So to do this, there's two ways we can actually accomplish this. Both are equally valid answers. They both get you to the same place. I start my flights data. I pipe it into filter, and I want all flights from December to February. So that means I want December, January, and February. So that's month 12, 1, and 2. And so I can just create a list of data, 12, 1, and 2 here. And just say if month is in one of these three values, keep it. Otherwise, chuck it. The other way I can do it is with or. So I can do filter month equals 1, or month equals 2, or month equals 12. Those are sort of the two ways we can do it. Does that make sense? We kind of follow? Cool. Let's look at the second one here. Filter flights that left late but had an on-time or early arrival. Okay, and assign it to a data set called comeback flights. So let's start with, we'll do this one together. Comeback flights. And filter flights that left late but had an on-time or early arrival. Okay, so I want flights that left, right? So I don't want those flights got canceled. So I need to filter out is.na. Let's say departure delay. Right? Kind of what we did up here. Get rid of all those NAs. And I want to do another filter here, just to keep these separate. Flights that left late but had an on-time or early arrival. So let's go into our data here. Get rid of that. So got the departure delay here. So I want only those values that are positive, right? So I don't want any negatives. I only want the positive. Oop, not bad. So I want departure delay is greater than 0, right? So they left late. We're going to be very strict about this. You know, I want them to be left late, right? And had an on-time or early arrival. So, and let's see, go back in here. Arrival delay. So I want on time or early. So I don't want them where they arrive late. I want them when they arrive either on time or early. So 0 or negative. So what is that called? Arrival delay, AR delay is less than or equal to 0. And that is it. That should be it. And I want to assign it to a new data set called comeback flights. If I go into comeback flights, how many flights does that get me? Well, it gets me roughly 35,000. If I open that up. So I've got a departure delay. So these are positive, right? These look pretty positive. And then the arrival delay looks like they came in early. Right? They all came in early. So these are all flights that had some sort of a delay associated with them, right? So you left your departing airport late, but they managed to make up the time somehow in the air, right? Have you guys ever had that happen to you where you left late, but you got there a little bit early? Somehow made up the time? Yeah. Usually it seems like they've been doing that a lot more often, which is kind of nice. But yeah, these are just flights that have left late, but they got there a little bit early. And let's go ahead and do this last one. Filter flights that flew to the Chicago area ORD and MDW. And so Midway Field and Chicago O'Hare Airport. Do the same thing here. Do I'm going to call this one Chicago flights. And I'm going to do a filter. Let's go back in our data set here. Which one of these is the so it's not origin, it's going to be destination. So dest. ORD, MDW. And if I open up Chicago flights, I should only have ORD and MDW. So these are all the flights that left JFK, LaGuardia, or Newark, heading to either Midway or Chicago O'Hare. Make sense? So doing these kinds of data manipulations is pretty, I guess, straightforward. Right? They are pretty powerful. They allow us to kind of really trim our data set down and hone in on particular features of our data set that are relevant to the questions that we want to ask. So, for instance, let's assume that, you are doing an internship at the NTSB and Congress is up in arms over the significant delays to Atlanta. What the hell's going on in Atlanta? Right? You guys are running a clown show down here with your airport. What's going on? Why are all these flights coming in late? Right? Like, what's with all these delays? And it allows you as the analyst to kind of go and say, okay, well, let's figure out what's going on. Are they leaving late? Are they leaving on time? Are they circling the airport? Right? What time of year are these happening? Are they happening? What happens in Atlanta during the summertime? What do we get? We get some storms around here, don't we? We get some pretty nasty thunderstorms, and we saw some of that, a couple of weeks ago. There may be situations that are sort of beyond our control, that may be relevant, for you as the analyst to really express that. Or there may be, in fact, reasons why, the ground crews are experiencing staffing delays, right? And so they just can't turn the planes around fast enough and it's getting backed up. I don't know if you guys remember a couple of years ago, there was the crowds. Do you remember the CrowdStrike outage? You guys remember that one? There was some global software that Delta ran, a bunch of other airlines ran, that just died one day. And literally like every airport in the country just ground to a complete halt. And I remember I was flying to Los Angeles that day and our flight got delayed, I think like 7 or 8 hours. Some people got delayed 2 or 3 days. They were sleeping in the airports. Hartsfield looked like, I mean, literally it looked like a scene out of like a movie. It was just people just piled up, like camping along the sides of the terminals. It was absolutely insane. Um, these delays do happen for a variety of reasons, and being able to filter these things out becomes increasingly, is important for you guys as the analyst. Let's see now. We did all that. We did a little bit of a range. We didn't do so much with select. I'm going to leave select for a later time. But I think here is a good place to stop. So before I let you guys go, do you have any questions about anything that we've learned today? Anything we've learned since last week that wasn't clear? Anything that doesn't make any sense?
I don't have any questions about what we learned, but where do I find the YouTube channel?
I'm going to post that here shortly. I'm going to get everything kind of loaded up and I'll send that link out to you guys.
Okay.
Yep, I'll send a link out with the homework.
Okay. Thank you.
Yes, ma'am. Good question. Anything else, guys? No? Cool. Well, that's all I have for you this morning. It's 9:30, so go off, do great things, and I will see you guys tomorrow morning at 8 a.m.
Thank you.
Thank you much, guys.
Thank you.
Yep,
See you
bye.
tomorrow.